At what point, x, y, is the paraboloid x squared plus y squared plus 2 minimized over the line 3y plus 5x equals 7? Okay, so our points have to be on this line. That constrains what we can be talking about. That gives us our constraint. Although we might choose to rewrite it so that it can more easily form a Lagrange function. Okay, it'll form it with the target or objective function, this expression x squared plus y squared plus 2, that we want to minimize. Okay. So we'll make our Lagrange function. So fxy lambda. You don't always have to use f. I do out of habit. Function we are trying to maximize or minimize. In this case, minimize. Lagrange multiplier. And then the function that is constraining us. In this case, this line. Okay, so 5x plus 3y, just to double check. Yes, 5x plus 3y. Okay. So maximums and minimums for Lagrangians can only occur at critical points. So we should take partial derivatives with respect to x, y, and lambda. Set them equal to 0, so to find those critical points. We get 2x plus 5 lambda. Deriving with respect to y, you get 2y plus 3 lambda. So these will have to be equal to 0. And then deriving with respect to lambda, we just get our constraint function back, as we always do. So, the first equation has an x and a lambda. The second equation has a y and a lambda. We can rewrite these to get x and y in terms of lambda, which is usually a pretty good strategy. So x will be negative 5 lambda over 2, and y will be negative 3 lambda over 2. All right. So now we can take those and plug them into our expression here. So 5 times negative 5 lambda over 2 plus 3 times negative 3 lambda over 2 minus 7 is equal to 0. We can clean that up a little bit. Negative 25 over 2 lambda plus negative 9 over 2 lambda needs to be equal to 7. Okay, so we can change that to negative 34 over 2 lambda is equal to 7. Or I guess we could say negative 17 lambda is equal to 7. Lambda is negative 7 over 17. Okay? That's the only lambda, and it's going to lead us to x and y, our only critical points, or our only critical point coordinates. So that'll have to be where this expression is minimized. And it's true that it will be. So what is our x and what is our y? So y was negative 3 halves lambda. Y was negative 5 halves lambda. So negative 5 halves times negative 7, 17. It'll be 35 over 34 for the x coordinate. And 21 over 34 for the y coordinate. So we get our minimum. Our function is minimized at 35 over 34, 21 over 34. Okay, and there we go. If we're interested, we can, of course, plug this into the expression and then plug values that are very close to this into the expression, and notice that this is smaller than everything around it. Okay? But we can just also trust the math. We only had the one critical point, so we don't really have to plug in and sort out who is the smallest. This one has to be the smallest.